G'day! In this series of videos, we are combining Psychopy and Python programming with Arduino and microcontrollers and the hardware. Because what we're trying to do is figure out a way of using our software or our Psychopy neuroscience program, Python programming, to control very low-level hardware. So things, in this case, it would be things like LED lights, but it could be something like a lick sensor or a photodiode beam or some form of transducer. And so what we've done up until now is we've learnt about the software that we've needed, the hardware that we've needed, and then we started to slowly build up our ability to program the Arduino. And we then shifted on into starting to look at serial communication between the Python and between Python and the Arduino. So if you haven't seen the previous videos, and you want to bring yourself up to speed, stop this video here, have a look at the first one, and then work your way up. If you have already done that, we should probably get cracking. Let's get started. So, in the previous video, we figured out a way of starting a serial communication 9600 board, and then what we did was we uploaded that onto the microcontroller, and then once we had power to the microcontroller, it would just sit there listening out on the port. In this case, it's dev CU USB modem 5D11. It's written down here. And when we then went into Python and started serial communication from Python, we hit the letters H or L, and we could then turn on or off that LED. That example that we did in that previous video is pretty much exactly the same as an example program that comes with Arduino. So if we look at examples here, go to communication number 4 and look for physical pixel. And if you have a look at physical pixel, it's the first sketch that comes up on the top. It's got some information there. It's written by David Mellis in 2015, and then it's been modified more recently. You'll see it's very similar to what we wrote ourselves. The reason why I didn't go straight for this example and just get you to upload it straight away is because I wanted to take you through step by step the thought process that you might want to go through when you start to think about communicating with the Arduino over the serial line, the sorts of things that we need to do. In the previous video, we only had control over one LED. What I want to do in this video and moving forward is to control 2 LEDs. In fact, they're going to be multiple LEDs, but conceptually what I'm trying to do is to design an experiment. Well, I've designed the experiment, but I want to design the hardware where I can control the left side of the arena, make that super bright, whilst keeping the right side dim, or making the right side bright, keeping the left side dim, making them both bright or both dim. And so therefore I need control over both LEDs, the left and the right bank of LEDs. So what I've done here is I've just worked my way forward a bit off screen, and essentially what I've done is I've created another variable called left LED, so that's going to be a constant integer. Remember, the other LED is plugged into pin 11 on the Arduino, and then that's going to this transistor here as well, the ULN2003A. And then what I've done is I've then set the pin mode for the left LED also to output. And then what I've done is I've said, okay, if pi byte, which remember is the serial.read, that's the latest serial byte that's been put into the buffer. If it's now an A, we're going to set the left LED pin high. If it's a G, we're going to set that left LED pin low. So I've just come up with A and G just off the top of my head. There's no significance on that, why those letters. So if we upload that now to the Arduino, what we're going to do is instead of running into our terminal here, we're going to go to the tools in the Arduino and go to serial monitor. So here we've got the ability to start serial communication with the Arduino itself using the Arduino software. So we've got 9.6K board here, 9600 board. So if we up here type H, we can turn on that LED. If we hit A now and hit enter, we can turn on that other LED. So instead of having to go through the terminal or the command prompt, you can use your serial monitor to interact with your Arduino. So I think it's G should turn that one off and L should turn that one off as well. So you can use your serial monitor. It's under tools in the Arduino tools. serial monitor. Now, be careful. If you have your serial monitor running in the background and then you go onto your Python and you try to start a Python session using the same port, you're going to get an error because this is keeping the Arduino busy on that port because it's basically controlling the communication. All right, so if you do come up with that error, and I'll force that error in a little bit, what I want you to do is close down your serial monitor and then try again. So hopefully that will clear up that serial resource. So what we can do is we can minimize our Arduino, work our way back into Atom now, Atom text editor, and I've saved this file as an scSerial led.py, and then in our terminal here, so what I'll do is I'll just minimize myself and I'll go for a bit of a fly. So I'm flying all the way down here. Okay, what we will see here is that if I see what's in here, I've saved sc_serial_led in the same folder as where I'm going to draw or call the Python script. Okay, what do I want to do? Well, firstly, we need to import some libraries. The library I'm going to import again is serial. If you don't have serial on your in your path, you're going to get a module not found error. So what you can do is you can go pip3 install PySerial serial. Okay, so PySerial contains the serial library. I'm using pip3 because this is a Mac machine and I want to put it onto the version 3 path. So import serial. The other thing that I'm going to import at the start is OS, okay? Because what I like to do is I like to clear the terminal output. And so the way that I do this, I say os.system, okay, I want to pass CLS to the system if the os.name is NT. So NT is for Windows machine. So if it's a Windows machine, it will pass this. Otherwise, or else, it will pass clear. So this one line of code can work on Windows, Mac, and Linux machines. What does it do? I'll just print a little OK afterwards. It should clear up the output on the terminal. So that should be saved. We'll write some muck here in the bash. Bash has got some weird things here. So what we're going to do is we'll run this program. You can see it's cleared it up and it's printed out that OK statement. So that's good. We are now clearing up our terminal output. So what do we want to do now? Well, we want to start serial communication. The way that we do that, the standard way of doing that is ser equals serial.S for the second serial. And then remember, this needs three arguments. It needs the port, it needs the baud rate, and then it also needs the timeout. What I'll do is I will set some variables up here. The variables here, and we're going to set the port equals dev cu.usb modem 5D11, and the baud rate we'll set this to just 9600 like that. Okay, and so now this value here will then be passed into here. And so if we run this now, and if everything's working, it will return nothing because we're not asking it to return anything. Let's force that error that we were talking about before. So here we've got the Arduino tools, serial monitor. We'll get that serial monitor up and running. We'll then try our program again. And you see, hang on, we've got error number 16. The resource is busy, and the resource that we're talking about is the port that we're trying to access. So if you do come up with this sort of error, just close your serial monitor down and try again, and it should work fine. So now, if we want to do something after and only after we start the serial communication, we can say if serial, well, let's just print out what we get first. Print, what does serial return? What does this call return? It returns the ID of what it is and the object, and it also gives us the variables and the states of that ser object. So we haven't set any parity. We've got 1 stop bits. We've set 1 second for timeout and all that sort of stuff. So if you want to probe just exactly what the object is, you can just print out the ser object. But what we're going to do is we're going to say if ser exists, we then want to basically start taking in, for this particular example, our keyboard input. So we'll say while true, because we want to continue on forever and ever and ever and ever and ever. While true, while true, we want to get LED input equals input. Now input is going to return a string, and we'll say, okay, if we want to play with the right LED, we need to send it a H or an L. If we want to play with the left LED, we need to give it the A or the G. And if we want to quit, we'll make that left. And if we want to quit, we'll hit quit like that. Okay. And so if the LED input equals Q, what we'll do is we'll go ser.close. So that means that we'll close the serial session, the communication session. Now Python should do this automatically whenever it closes down, but it's a good habit to get into control, to manage your resources yourself. And so we'll close that down, and then we'll break out of this loop, and this should give us a good return. Back, LED input is not defined. What have I done wrong? Line 22, LED input is not defined. Okay, it's because I've done the equivalence there. It's just an equals. Right, okay, so if we hit Q, it should return us back, and it does, which is great. So we haven't written anything else, so what we should do now is put in some control statements, and we say, okay, if LED input equals H, we want to turn on the right LED. So we'll go ser.write H, because remember, that's what we've got on our Arduino code. So if we've got H coming in, the right LED will be sent high, and that's what we wanted to do. If LED input equals L, we want to turn off the left LED, so sorry, the right LED. So we'll go ser.write this like this. And then do the same thing for A. Oops. That was an autocomplete from, we don't need that there. Now I'm writing this the long way around, just to get you to think about the structure of the control statements here. You can optimize your code as you see fit, as you want. Okay, B, and then that will go to there. If this all works well, and we haven't made any mistakes, if we hit now the H, we should turn on this LED, and if we hit L, we should turn it off. Great, this is what we're doing. We've now got it running through our software. If we hit A, we should turn on that other LED, which we do. Let me just face this one back this way for you. If we now hit H, we should be able to turn that one on as well. We hit G, we can turn that off. We hit L, we turn that one off. So here we have continuous control over the left LED and the right LED. But you'll notice that the LED, if we hit H, for instance, we're turning that one on, and it's staying on forever, or until the power, this power here turns off, or the Arduino power is interrupted, or we've reset the Arduino serial communication. So what we can do now is we can either control the duration of the LED using software, or we can control the duration of the LED using hardware. So the first way we're going to do this is using software. So I'll send this low again. So we'll go low, we'll quit out of that. How do we do that? Well, if you've followed me in the Psychopy tutorials, we can use core. So from Psychopy, import core, and you remember core.wait. So core.wait, and then that will accept a single argument, and that's in seconds to wait, and it will block the execution of the code until that timer has returned a finished flag, basically. So we can write that high for 2 seconds, and then we want to send it low, that pin low again, after we've sent it high for 2 seconds. We want to control the time for 2 seconds. So how do we do that? Well, we just write the same command as if we were sending it low. remember? If we send it an L command, Arduino will send that pin low. So here we should have software control over the timing of the LED. So if we hit H now, it should turn on for 2 seconds and then turn off because we've used core.wait. The other way that we could set the timing, if we weren't familiar with Psychopy, is we could import the time module and then we could say time.sleep. Okay, we'll see what happens. We'll set this high. Okay, nothing's happened there. Let's try that again. 1, 2, off. Okay, so that's also worked. We'll go back to our core.wait. Okay, core.wait. Oops, 2 seconds. So that's software control over timing. What if you want your Psychopy program to continue to do other things, update a visual display or to do some other background housekeeping things? What we can do is we can offload the timing. I'll just delete that. We can offload the timing onto the interrupts or onto the hardware itself. And the way that we do that, remember, is a couple of programs ago, we got the LED to blink on and off by setting a delay. Okay, so if we go delay, say 2000, remember this one's in milliseconds, and then we go digital right LED low. Okay, we'll save that. We'll then upload that. So now all of the timing is going to be controlled by the microcontroller itself using its own internal interrupts and its own delays. So we run this program again. Now if we hit H, it should turn on for 2 seconds and then turn off after 2 seconds, and that was done completely independently of the software. So that software could be working on some other things now. We haven't put a blocking routine, that core.wait, in. Now this could be helpful, like I said, if you want your program to do things outside of your timing of your hardware. And the Arduino is actually quite precise. You can get pretty good timing. However, what you've lost now by setting a delay or setting timing of your hardware without any further information or communication between the two software and hardware, you've basically lost any synchronization between the two. Okay, so basically you've now set an internal timer, okay, which should be internally consistent on your hardware, which is going to be independent and could be separate from the timing of your software. Okay, so you have to be a little bit careful if you can accept that, or if whether or not you need to have a strict and rigid timing, which is driven just from your software or just from your hardware, because you can get your Arduino to send a command back to your Python program to say, okay, I'm done. This is the timestamp. Let's start again. We're not going to get into that in these videos. We're just keeping this simple, one-way communication. Okay, so we can now control the timing of the LEDs using software or the hardware itself. So let me just go back to the Arduino, make sure I've turned that off. So I'll delete this now because I don't want this. What we're going to do now is we're going to think in a slightly different way about controlling the LEDs, because what we're doing is we are having to put in 4 commands into our software to turn on and off our LEDs. The other way that we can think about it is to say, okay, well, the LED can either be on or off. And so that means that the LED is either in one of 2 states, the state being on state or an off state. So what if we wanted to toggle between the on and off state, just back and forth, by putting in just a simple or single command? Can we do that? Well, yes, we can. We can create basically a state of the LED, and then we can just look at the state, make a decision on what we need to do, and then update the state of the LED. Now this should be important, this should be clear when we go through it, okay? So we have to initialize the state of the LED. And so the way that I'm going to do that is I'm going to say, okay, the right LED state equals -1, and I'm going to say that -1 is off and 1 is on. So if we ever set the right LED state to 1, that means that LED is lit up. We'll do the same thing for the left LED. State equals -1. Now I like to initialize things to an off state, and then this is ditto for above. So now we've initialized the state, we've put it outside the while loop, and then we say, okay, if we want to play with the right LED, we just have to hit the R button, and if we want to play with the left LED, we'll hit the L button. And so now we say if the keyboard input, LED input is right, okay, so we want to change the right LED. We then have to say, okay, well, what is the current state of that LED? So we say if right LED state is -1, that means the LED is off, okay? We want to turn it on. We want it on, or we will transition it to on, okay? So how do we transition that LED on? Well, remember, we have to set that pin high. How do we set that pin high, the right LED pin high? Well, if we look at the Arduino code, we just have to pass it the H. We have to set the right pin high by passing a H. And so we just have to write sir.write BH. Okay, that's all we do. Now, else, if the right LED state is in fact 1, that means the LED is on and we want it off. How do we do that? Well, sir.write, remember the way that we set that low is by passing the capital L command. Done. So now we have just looked for the state and then we've made a change, or we've written to the serial line the updated state that we want to do, or the updated logic on the microcontroller pin, setting it high or low. Excuse me. But what we need to do now is we need to update the state, because the next time we come along and hit the R button, we want to then look at the new state, the state that we've just set, and then update it or make a decision, change the logic on that pin. So right LED state equals minus right LED state. And I'll leave it up to you to figure out what it is that we're doing here. So the hint is a negative of a negative is a positive. And if we take the negative of a positive, it's going to turn negative again. Okay, so you might want to just print out the right LED state before and after we do this right LED state. What we're going to do is flip between -1 and 1. And the way that we're doing that is putting this minus sign in front of the current state. So this should hopefully work for the right LED. What we're going to do now is just run straight ahead, and we'll do the same thing for if we want to play with the left LED. So if LED input equals left, okay, that means we want to play with the left LED. And then we ask ourselves, okay, so if left LED state is -1, that means it's off. We want it to go on. So how do we set that? Sir.write B, we want that on, so that's the capital A. So we want to set the left LED state on because it's currently off. So we go back to our Arduino code and we say, okay, how do we set that? How do we set that? To set the left LED pin high, we have to give it the capital A. That's what we've done there. And then we say if left LED state equals 1, okay, it is on, but we want it off. And so something like this. And then what we need to do is, remember, we need to set the state. So left LED state equals minus left LED state. We'll make this at the correct indent. Okay, so this should update the LED state, and then the next time we come and get the input from the keyboard, it should then go through this logic again. If we've done it all correctly. Let's see if we've got any problems. So if we go R, that should turn on the right LED, and then it's turned off again. Why is it turned off again? I think it's because we didn't upload, maybe we didn't upload that, that new code by removing out that delay. So let's try this again. We'll go back here. So that's on. Okay, so now if we hit the R button, it should turn it off. Because remember, once we've set it on, okay, it then comes down here and then it updates the state. And so now the state of the LED is in fact 1. And so therefore, when we hit the R button again, it will go, if LED is R, yep, that's correct. No, that's incorrect. We're now at +1. And so therefore it says, okay, it's at +1. We then write that serial command. We write that digital pin low, and then we update. So now this was -1. Sorry, this was 1. And so now it's -1, which says that that LED is off. Okay, so we're setting the state and we update the state. So let's see if the other one is working. So we want to play with the L one. Okay, so left state is not defined. So I've got an error here, 42. Okay, so left LED state. So here we will try left. So that's turned on, okay. And then if we hit the left again, it should turn off. And you see we've done nothing on the right side there. So this is how we can toggle between the left and the right, turning them on and off. So left on, right on. We can then turn the left off and then the right off, and then the right on, and then the left on, and then the left off, and then the right off, okay? So here we are just setting the states of the LEDs, and it's a bit of a different way of thinking about how to control your hardware devices, or controlling, in this case, LEDs which have one of two states. Make sure you update the state after you've written something. Make sure you update the state after you've changed the state. Okay, so we'll leave this video here. We've got quite good one-way control, one-way serial communication between Python, Psychopy now, and the Arduino. We've also gone through timing, so we've got software timing using core.wait or time.sleep. We've also gone through hardware timing, where we set the delay on the Arduino itself, and it was happy to do that function using its own internal interrupts, and we could then go back and do our own thing in the Psychopy or in our Python script. What we're going to do now in the next video is we're pretty much done. We've broken the back of what I wanted to achieve here. In the next video, we'll just, I don't know, we'll do some fancy visual, we'll do some Psychopy programming, and just so you can see how to slot in your serial communication inside an existing or inside a larger Psychopy program. But look, if you're not interested in that sort of stuff, you can probably leave this here and you don't need to see the next one. If you are interested, look, I'll stop this one here. I'll have a think about what we want to do, and then I'll start recording the next video. All right, so good luck, and I hope you found this helpful. All right, I'll see you around.